Hi guys, my name is Ali and today we are talking about the measures of central tendency. In the last lecture, we actually discussed on the standard normal distribution curve, and in this curve we mentioned the population mean. So I'm going to continue with the mean today. Before we continue with the mean, let me introduce you what is the meaning of population. So let's suppose this is one set boundary, and in this one this set boundary is your area of interest. So we call that your area of interest. In fact, this boundary is quite big, and we do not have the resources to access each and every person in this boundary. So we simply focus on a smaller portion, and this smaller portion will be your sample. So that thing will be your sample. And this area of interest, that will be your population. Now we come back to the Excel sheet. Let's suppose we have 5 observations, and in other words our sample size is 5, and these are the values associated with that sample. So 400 for 1, 425 for 2, and so on. Let's make it more meaningful. We assume that these numbers are represented in thousands, and they are actually reflecting the price of a certain property. So the price of the first property is 400,000, second one is 425, third one is 415,000, and so on. And if we take the average of all these numbers, we will see the average is 568,400. However, this average is not the correct average. If we round it, we will get 570,000 in general. This is not how we round in statistics. But let's suppose you are the real estate agent and you are talking to a consumer. The price you tell to your consumer will not be 568,000. You might say it's about 570,000. So that's what we say in our general speaking. You can see there are some figures in the prices that are quite high or quite low. So 1.6 million is quite high, but 2000 is quite low. So these two numbers are going to affect the price of the property itself. And our average, in which we are saying that the price is around 570,000, is not reflecting the actual values. In order to reflect the actual values, all values ideally should be very close to each other. Otherwise, the average will be affected by the extreme values. In this case, 1.6 million is the extreme value. 2000 is also the extreme value. So if the values are very close to each other, then our average is likely to be more accurate. But if there are some outliers, so this is an outlier, this is also an outlier. But if there's some outlier, then they will distort the average. In other words, we can say that the mean is affected by the extreme values, or we can say here outliers. If mean is affected by the extreme values, which we can see in this case, then what is the alternative measure of central tendency? The alternative measure is the median, because it is not affected by the extreme value. And the median, after placing the formula like that, it gives us the value of 415,000, which is more accurate because we can see that if the values are close to each other, we again get value close to 415,000, but this is again what we will say in general terms. This is not how we calculate the average. So how can we calculate the average? What rule should we use? We have used the formula for the average. We know it is 416,000. But what's the formula for rounding? So we can say conditions for rounding so the condition is that if the value after which you want to round has to be greater than or equal to 5. So it should, so I'm writing here greater than or equal to 5. So let's suppose we decide that we need to round till the first 3 digits. Now the fourth digit is 7, so this means we need to add 1 in 6. That becomes 417. If in this case you can see the next digit is 4, which is less than 5, so we will leave it like that. It becomes 416. If the digit is 5, this is equivalent to 5, so we will again round it to 417. And the accurate average after rounding is 416,000. Here it is not an issue because the number after 6 is 0. It is less than 5, so we don't have to round. But in general speaking, we will say 415,000. And median is very close to that 415,000. This is actually equivalent to that. So when the values are extreme, just keep that in mind. Prefer median. But if the values are close to each other, prefer mean. And in most of the statistical calculations that we do in inferential statistics, we assume that the values are close to each other. There are no outliers. If there are outliers, then we cut them off. There is a 5% method for that. So, and when there are no extreme values, our mean gives us the accurate number. So I write the rule here. If extreme values exist in the sample, use median. Otherwise, use mean. If you think this is a very complex sentence, I can make it here. If extreme values do not exist, use mean. Do not exist where? Exist in the sample. exists in the sample, use median, so I simply delete that. So we have two rules here. Then we talk about the mode. The mode is the most frequently occurring value. So let's suppose one value is 415, another one is also 415, third one is 200, 200, 200, fourth one is 600. Okay. So what will be the mode of that? The mode is the most frequently occurring value. So we write here most frequently occurring value. So if we see that what will be the mode, simply click on this, select all values, and the mode is 200. The 415 is also repeating, but most frequently occurring value is 200. So mode is 200. Let's suppose we have another value 300, 300, 300. We extend the formula. Let's see what we get this time. It is again giving us 200, but in fact it is bimodal. We have 200 and we also have 300. So we have two modes. So we can say that a population, or in this case a sample, can be bimodal. So in this lecture we talked about the mean and what factors affect its value, in which situations mean is preferable over median and vice versa, and mod and bimodal as well. So that's all for today. Next time I will come up with a different concept. Thanks for watching. You can pass your comments down below and we will be in touch. Thank you so much.